We learned yesterday about non-permissible values, and I don't want to really spend a lot of time, if any, talking about it right now. It's the kind of thing where every time we encounter it, we learn more about non-permissible values. The main thing is you're getting used to, from yesterday and continuing to today, you're getting used to the language of algebra with trig. You're working with fractions that are trigonometric. You're working with rational expressions that are trigonometric. So instead of having things from math 20-1 like x squared minus 4 over x minus 2, you have instead sine squared x minus cos squared x over tan x, or something along those lines. And I'm saying that in order for you to simplify a trigonometric expression, here are the following strategies that you can try. And this is not necessarily the order that they're always going to work in, but my go-to method is always to replace everything with sines and cosines, unless I see something obvious, like I see on the top of a fraction 1 plus cotangent squared of x. I believe, if I see 1 plus cotangent squared of x, my brain says, you know what? There are those three Pythagorean identities that each have the number 1 and squares of trig ratios. And I don't remember them, so I always have to look. If I take a look at those Pythagorean identities, look at that. 1 plus cotangent squared of x is cosecant squared of x. So rather than writing 1 plus cotangent squared of, I'll go with theta, rather than writing 1 plus cotangent squared of theta as 1 plus cos squared of theta over sine squared of theta, which I could do, I would just write it as cosecant squared and then write it as 1 over sine squared. So these are simply suggestions. You know, they're different paths that you can follow. Obviously, you're always looking for known identities, like sine squared plus cos squared. Sine squared of theta plus cos squared of theta is equal to 1. 1 plus cotangent squared of theta is equal to, did I just see secant squared of theta? Okay. Always try to factor if at all possible. If you can factor something, then sometimes it becomes simpler. Okay. If you have fractions, and we'll talk more about this in detail and the reason for it, but if you have multiple fractions that are added or subtracted, we want a single fraction. And the reason for that is this. When you cancel, quote, cancel things in math, you're canceling things because the thing you get rid of on the top and the bottom is a factor of the top and the bottom. But it only works if you have a single fraction. If I have, going back to math 20, if I had 1 over x plus 2 plus x plus 2 over x minus 3, I cannot cancel those x plus 2's. In order to find out what, if anything, I can cancel, I have to put these fractions together. Because, and math 20-1, that rational expressions unit is so crucial to your success here. Because if you have a single fraction and the top is expressed as a product of factors, and the bottom is expressed as a product of factors, then you can cancel. I can cancel the two C's. I can cancel an A and an A. I can cancel a D and a D. But you cannot cancel unless it's a single fraction. And I want to get to doing the math here, but I also want you to understand why we're doing what we're doing. This is why you put fractions together, so that you can reduce them. And then, of course, you know, you have to be crafty and smart about this. Whatever you decide to do, there's an art to this, because whatever you decide to do, it might get really messy. And if it gets, quote, too messy, go back. But power through and see if past that messiness, a couple of steps past it, all of a sudden it clears up, because it might. You might have to fight through that messiness to get to a result. So today what we are doing is we are working on all of these problems, the 5 to 23, plus all of those problems that are additional practice problems outlined in your handout. And you need to understand something about learning this. You will learn it by doing it, but you would also learn it a lot by watching me do it. So let's start with that. Does anybody have any questions you would like me to go over here in this handout? Go ahead. 5A? F. 5F. I retyped everything into this document, so periodically today I will just ask, is that the same expression? Okay. So what you would preferably want to do here is start by converting everything to sines and cosines, or writing everything as sines and cosines. And right now, this is two expressions, right? It's two, not expressions. It's two terms. There's a plus sign in there, okay? And I want to contrast something here. I want to contrast this, which I'm just going to leave up on the other screen, sine theta plus cotan theta cos theta, with something like this. There's a fundamental difference mathematically between these two expressions. The one that you're looking at on the screen right now is a product of things. There's no pluses or minuses. And that means, everybody, that if you change everything to sine and cosine and clean it up a little bit, you will be allowed to cancel wherever you want, because you just got multiplication along the top and you've just got multiplication along the bottom. But when we take a look at what's on the right screen, and I'll go back to it now, the question that you're asking about, there's that plus. Okay, so keep that in mind. That's what really changes this from the previous one I just looked at. So we're going to write this as sine of theta plus, and because cotangent of theta is a quotient or a fraction, I'm lining things up. So first of all, I hope everybody's okay with the fact that cotangent of theta is cosine of theta over sine of theta. That's that quotient identity. But I'm lining things up so that numerators are on the same line physically when I write it, and denominators are all on the same line. And then I have times cos of theta, so that's times cos of theta. And I can certainly condense or simplify this second term. Because when I'm multiplying fractions, and again, this is why that rational expressions unit from Math 20 is so important. This is all rational expressions. When I multiply fractions, a rational expression is an algebraic fraction. When I multiply fractions, I multiply across the top, and I multiply across the bottom. Now, I have two terms. You may not look at them this way, but the fact of the matter is, I have two fractions. And there's nowhere I can go until I put them together with a common denominator. So this would be very similar to me having two fractions where one of the fractions was something over 3 and the other is something over 5. The least common denominator here would have to be 15 because it has to include this factor of 3 and it has to include this factor of 5. Okay, I want to do a quick review here of something. Are you with me on that? Okay. However, if I had it doesn't matter. 6 and 2, my lowest common denominator will not be 12. And the reason is 2 is a factor of 6. And how I teach this last year in Math 20 is I say your lowest common denominator has to contain all of the factors of each denominator. So this 6 is a 2 and a 3. Okay, so starting with the 6, my lowest common denominator has to represent each factor in that denominator. So it needs to contain a 2 to represent that factor of 2. and it needs to contain a 3 to represent that factor of 3. And that means, and I know that this is very elementary math, but it's going to scale up very shortly. That means that that denominator of 2 times 3 is represented in my lowest common denominator so far. Now, I move on to the next denominator. It contains a single factor of 2, which means my lowest common denominator must contain a factor of 2, but it's already there. Okay? As a result of that, when you think about a lowest common denominator here, it has to contain a factor of 1, which is, I would say, trivial. Everything contains a factor of 1. And it must contain a factor of sine of theta. And I've gone through an elaborate explanation of why the common denominator is sine of theta, but I know what's going to happen probably later today. I'll need to refer back to this in more complicated cases. Okay. When I look up here, the second fraction is already over sine of theta. It's already the right version of itself. But the first fraction is only over 1, so to get it to be over sine of theta, I need to multiply the top and the bottom of this expression by sine of theta. So I get sine squared of theta on the top over sine of theta. I want to pause for a second here and talk about a written response question. And this is not just a really easy question. This could be a 2-mark written response question along with, as well included in the 2 marks, what are the non-permissible values of theta? Okay? But I want you to imagine that somebody is marking this. They're looking at your work. And what they see is that. I mean, the markers are smart. I'm clever enough to understand what's going on there. But if you have a different color pen, I think it's a really good idea to do that. To kind of tell the marker, well, what I'm doing is I'm converting, I'm multiplying top and bottom by something. Otherwise, it's just this mess of algebra sometimes. Just keep that in mind. Or, maybe if you don't want to do that, a suggestion might be to, somehow indicate that it's something different that you've added on afterwards. Later on, you've added it on. Anyway, now we can put these fractions together and get an entire fraction with the denominator of sine of theta. And then on the top, we have sine squared of theta plus cos squared of theta. Hello, old friend. That's equal to 1, right? We've met this person before many times, even though it's been less than 24 hours since you've seen it. You've seen it a lot. So what we end up with is 1 over sine of theta. And I believe what we were asked to do here, I better just check, just simplify. Now, you are asked to simplify it to a single trigonometric ratio. Is this a single trigonometric ratio? Well, kind of, but a better way to write it is to say cosecant of theta. And even if you got that question already, trust me, and I hope you would agree, that 5-10 minutes, you will have picked up something else. And remember what I said yesterday. Your goal is always to be better at this now than you were 5 minutes ago, or an hour ago, or yesterday, or last week. I hope you're better at it now than you were last week. Because last week you didn't know about it. Other questions? Go ahead.
Number
10? Okay. 10 is an interesting question. And I always include a question like this, and it's always asked about. Very few people do it and go, oh, I get it. The thing that's frustrating here about this is you follow the rules and you get an answer and you feel confident in what you've got, but the answer's not there. Okay. So I think this is a perfect opportunity to write everything in terms of sine and cos. And I'm glad you've asked this question right after the question we just did. Remember there was that plus in the question we just did? Okay. There's no plus here. It's a single fraction already. So when I write this in terms of sine and cosine, I get the following on the top. And I've written that cos squared of A as cosine of A times cosine of A for people who might need or benefit from seeing it that way, because then I really can drive home the fact. See those brackets? That tells you everything in each bracket is a factor. That's important. But that's just the numerator of the fraction. The denominator is secant of A, and secant of A is 1 over cosine of A. And my hope would be everybody is fine with that. Everybody is fine with taking a tangent or a cotangent or a secant or a cosecant and writing them as sines and cosines in some way. So you could potentially get ahead of yourself here right now and start canceling. Because Mr. Way said if you have brackets, you can cancel, as long as there's no pluses, right? But the issue here is this, and I want to go through this we have time, and I really want to do a good job with this. I don't want to rush through anything today. What we have is a fraction, a big fraction. And on the top of the fraction, this entire thing here is the numerator of the fraction. And this 1 over cos is the denominator of the fraction. But the issue is that within the numerator of the fraction, there are denominators, right? This cosine, well, there's a denominator, this cosine of A. And in the denominator of the fraction, there's a denominator. So this is what we call, this entire thing is called a complex fraction. And you may not think at first that language is that important in math, but when you're learning math, language is important. Because if I say in the future, oh, we're dealing with a complex fraction, now you know what we're talking about, right? And that being said, you should already know what a complex fraction is. And I use the non-mathematical phrase here, it's complex because there are many denominators. And we would much rather have a simple fraction than a complex fraction. So all that being said, what we need to do is multiply the entire top of this and the entire bottom by whatever we need to get rid of those many denominators. Now, because I've added all kinds of stuff here, I don't want to delete it, I'll just clone it. Because I've added all kinds of stuff here, I want to go back. Oh, I guess it doesn't work that way. I want to go back to where I was. Because I'm about to multiply the top and the bottom of this by something, and all that box would do would be to confuse the issue visually. So I have to multiply the top and the bottom by cosine of A to clear those many denominators. Now, I'm teaching you a lot of Math 20 right now, actually. I could just get to the answer. But I want somebody to explain why, when I multiply the top by cos of A, I do not do that. That would be wrong. Why don't I multiply everything on the top by cos of A? Maria, do you know?
Because cos of A is in the denominator, so it cancels it out.
Right. The bottom line here is these things are multiplied together. When you multiply everything together, fractions, you basically get one fraction. Cos of A is in the denominator, so it multiplies and it cancels. When would you multiply, so I want to get rid of those arrows before I forget. When would you do that and go cos of A, cos of A, cos of A? When would you multiply multiple times? Basil, do you know?
When there's separate terms.
right? If there are separate terms, if it was sine of A over cos of A plus cos of A, then you would distribute it. But if I'm asking you to multiply, you only multiply the entire thing by that. So anyway, we're so close to being done here, except for the wrinkle in this question. This cancels here. This cancels there. So this is beautiful because we don't even have a denominator. We're left with a single term that is not even a fraction. And what do I get on the top? I have a sine of A times a cosine of A quantity squared. And you go, well, I'm pretty confident in what I did, and I look, and I feel deflated all of a sudden because the answer is not there. So let's just take a break from this question for a minute and talk about that, what I would call the most famous identity. I'll use A's. Right? This Pythagorean identity is one that I'll bet you anything. Seriously, 10 years from now, if I just said, you did identities in trig and we talked about it a bit, you'd go, oh yeah, I remember that one. You would remember it. And I've asked you, everybody, to keep your eyes peeled, which means open and aware and alert, for this thing. So when you see sine squared of an angle plus cos squared of an angle, you go, I can put 1 instead, right? But, and I might have mentioned this yesterday, but I'll mention it again. If I subtract cos squared of A from both sides, if sine squared of A plus cos squared of A is 1, that means, another fact, sine squared of A is 1 minus cos squared A. And now what I'm asking you to do is be aware that this is something recognizable. Now, we're going to be going in the opposite direction here, but I'm saying if you're working on something and you see 1 minus cos squared, you should go, hey, you know what? I'm going to change that to sine squared. Or, if I take this original identity and I subtract sine squared, I have that. So I know I'm really piling a lot on your shoulders in terms of responsibilities. I'm asking you, or telling you, I guess, that you need to be on the lookout for those 3 things. And there's 2 more that we'll get to, either today or tomorrow, or the next day. There's another couple of variations of this. So what we can do here is when you look at this question very carefully, it says we need to express everything in terms of sine of A. And at the bottom of our work here, we have a cos squared. So we can put in 1 minus sine squared of A. And right away I can see a lot of you, oh yeah, you're seeing it now, because if I multiply, oh, this is interesting. If I multiply this through, I have to distribute it because of that minus sign, right? There's 2 different terms. I'm going to get D. I'm going to get sine of A minus sine cubed of A. Does that help? Okay. Other questions? Yep. 22? Once again, I'm just going to ask you, Cyrus, to confirm, because I had to retype all this, that the expression number 1 is secant theta minus cosecant theta over cotan theta. The second expression is tan theta cos theta over sine theta. And the last is tan squared minus secant squared minus 1. This is a classic kind of question that you would see on an exam. This stuff here is, you know, the parsley on the fish. It's not really doing much in terms of the work you're going to do here. It's kind of decoration. It is important because, you know, for example, in expression 2, you're dividing by sine of theta. So sine of theta is not allowed to be 0, but it's not used in coming up with the answer here. Very often you're given a question like this where the trigonometric expressions are actually equal to a number. Now, we're going to end up You're going to know this sooner or later, so I'll just reveal it now. If you got really stuck, then you could pick a number for theta like 30 degrees, put your calculator in 30 degrees and see what this is equal to, which is frankly quite a bit of a pain to put it in. And then you could try it with 20 degrees or with pi radians, and you'll always get the same thing. I misspoke. Maybe not with pi radians, because with pi radians, sine of theta would be equal to 0. Okay? However, the intention here is for you to simplify these. So I'm going to take them one at a time. Secant of theta minus cosecant of theta over cotangent of theta. I think. Yep. So let's write everything in terms of sine and cosine, and this is all beneficial. Going over all of these is building those trigonometric muscles in your brain. So this is 1 over cos of theta. Cosecant of theta is the reciprocal of sine of theta, and this is over cotangent of theta, which is cosine of theta over sine of theta. And, you know, speaking about keeping things lined up, this is fine, but really it's this. Right? This is what we're talking about. If you want to be really picky. However, this second term, this cosecant theta over cotan theta, which is equal to 1 over sine of theta over cos of theta over sine of theta, is a complex fraction, right? It contains these pesky little mini denominators. So we're going to multiply the numerator and the denominator of this complex fraction by sine of theta. And I think many of you will see that this entire thing is going to be 0. Because when the sine of thetas cancel, when all the dust clears, you're left with, on this second term, 1 over cos of theta. So it's 1 over cos of theta minus 1 over cos of theta. 0. We know the value of this is 0. And the tricky thing here is, don't confuse these numbers we're getting over here with the expression numbers. Expression number 1 has a value of 0. Now we go to the second one. This second one's going to be easier because there's no pluses or minuses. It's a single fraction already. I am curious, how many of you see that that's equal to 1? Tan theta cos theta over sine theta. Let me start with this. How many of you see that this is sine theta? Because the tangent is sine theta over cos theta. Okay. But to officially kind of write it out, we have tan theta cos theta for expression 2 over sine theta. This is sine theta over cos theta times cos theta in the top. And in the denominator, we have sine of theta. We don't need to multiply top and bottom to clear out that cos of theta as a mini denominator. We were gifted that extra cos theta there. So now, I would say to you that I hope everybody recognizes this is sine theta over sine theta. I don't think it hurts on a written response to write that and then to say it's equal to 1. So expression 2 has a value of 1. What about expression 3? Well, there is something that will often supersede tip 1, which is to write everything in terms of sine and cosine. And it's Pythagorean identities. And as soon as you see a bunch of squareds being added or subtracted, try to think of Pythagorean identities. So is there something that I can replace tan squared of theta with? Or is there something I can replace secant squared of theta with? And tan squared of theta is equal to, I believe, 1 plus, secant squared of theta minus 1. Is secant square root of theta in expression 3? Okay, well, why don't we, instead of doing that, if secant square root of theta is equal to 1 plus tan squared theta, why don't we just make that substitution here? Why don't we just put what did I say secant squared of theta was? 1 plus tan squared? Okay, so I put 1 plus tan squared of theta. I mean, you can't run from basic algebra. You need to have some basic skills. That you better put a set of brackets around that 1 plus tan squared. And then you can say, I have tan squared of theta. I have minus 1. And I also have minus tan squared of theta. In earlier grades, particularly maybe grade 9, you might be instructed to multiply that negative through. I just say we're subtracting everything. And then we also have this, don't forget about this minus 1 here. And you can see that you get negative 2. Because tan squared of theta minus tan squared of theta is nothing. Negative 1 minus 1 is negative 2. I kind of painted myself into a corner here. This is the value of expression 3. So the lowest value is negative 2, which is expression 3. So you would put a 3 in the first blank. The highest value is 1, which is expression 2. And the value in between the two is 0. See, it's not, is 0, which is expression 1. So you put 3, 1, 2. Is that good? Okay. Other questions? On page 38 of the handout, we're looking at 2c. It's 1 plus 1 over tan of x over 1 over tan squared of x. And have to wait for my computer to just catch its breath here. Didn't get it? There it is. The first and foremost, you should always be looking at writing everything as sine and cosine. But I think, since this is a complex fraction, imagine what would happen if you changed that tan to sine over cos. It would be not a denominator within a numerator. It would be a denominator within a denominator within a numerator. So I think it's best to clear up the complexity of the fraction first before you start running away with the trig. In other words, do some algebra to simplify things, then we'll worry about the trig. And I'm just going to choose to rewrite this. It's just a little too small for my taste. 1 plus 1 over tan of x. And in addition, I'm also writing it with a slight variation in how things are lined up. The way this is written is fine. But I hope you understand that leading 1 is a numerator. So that's what I'm doing, okay? So now I'm going to multiply top and bottom of this, everybody, by tangent. Well, I need to multiply by whatever will clear all of the denominators. Now, if you say, well, I'm going to multiply the top and bottom by tangent of x to clear the tangent of x on the top, you're going to be left a little short on the bottom because that will only cancel one of these tan of x's that are in the tan squared of x. Just momentarily, that's what we have on the bottom, right? So by multiplying the bottom by tan of x, you cancel one of those, but I want to cancel them both. And that means, everybody, you could certainly write it as tan x in the denominator of the denominator. You don't need to. We're going to multiply top and bottom by tan squared. And a beautiful thing happens here. The denominator of this entire fraction will be 1. So not only have we cleared the complexity of the fraction, we've kind of gotten rid of it even being a fraction. So what will we have left? We will have tan squared of x. So I'm multiplying this that's highlighted in yellow by this, and I also need to multiply what's highlighted in yellow by that, right? That's the distributive property in math. So I get tan squared of x, and then when I multiply the yellow by the blue, what's happening is the tan squared of x is, oh no, they don't. It's tan of x. I momentarily, we're okay so far?
Yep.
Okay. I momentarily thought that this was a tan squared of x, but do you see how one of them cancels? Okay. Now, in this particular question, I want to go back to the handout and see what it is we're asked to do. Write with a common denominator and simplify if possible. This is going to be a frustrating thing for you, and it's a frustrating thing for me. When you have an open-ended question, it's not multiple choice, and it says simplify, what does that mean? I think that's simplified. If you want to start writing everything with sines and cosines, let me show you what it would become. Is this the answer, by the way? They take out a tan x, they factor a tan x out. But look at what would happen if you did this. Let's say you wanted to walk down this path, and that's okay, this is right. Now you have to find a common denominator. The common denominator, and I'm going through this for everybody's benefit, but in particular for calculus students' benefit. Okay? If you're not in calculus, you should still follow and understand and appreciate what I'm saying, but it's not that big of a deal. Cyrus, do you see that in order to convert this fraction, sine of x over cos of x, to a denominator of cos squared, it's going to become sine x cos x over cos squared. Okay. My question to you is then when you put them together, here's what we had, right? So when you put them together, you get this. My question to you is, why bother? This in no way is easier to work with than this. You might say, well, I'm going to factor out a sine x. Well, that's not going to lead anywhere either. Is that okay? Okay. So I think there's really only one direction you can start walking here, and it's to change the secant to 1 over cos. And then you look at this and you go, okay, and interestingly enough, one of the things on that list is factor if possible. That doesn't come up a lot yet, but it's going to start rearing its head at us soon. So there's nothing to factor. I don't recognize anything. And by the way, some people will go, oh, wait a minute. They'll think for a second and they'll be distracted and they'll go, wait a minute, isn't this secant of x? And they'll write secant of x. Well, then you're just going back to the original question, right? The only thing left is to compose a complete fraction from these two separate fractions that are being subtracted. And the lowest common denominator here would have to be cosine of x. And that means that I'm going to need to multiply the top and the bottom of this by cosine of x. I think where you went wrong, and I know where you went wrong, and I want to talk about this with everybody. And it's okay that you did this because it is something that happens a lot, particularly in Math 20. So everybody maybe just stop and follow along here. What we started off with is secant of x minus cosine of x. We've written secant as 1 over cos and then minus cos. So what's in brown is the original question. And I've said I want a common denominator. And the common denominator is cos of x. And it's accomplished by multiplying top and bottom of this cos of x over 1 by cos of x. And you get 1 here, it's already over cos of x, minus cosine squared of x. So this is correct. Okay. Now, I'm going to finish the question, and then I'm going to tell you what you are not allowed to do, which people will do. I recognize that this is sine squared of x, and that means I have sine squared of x over cos of x. And I'm just curious, how many of you do see, in fact, that that's that? What you might have to do is write this sine squared as sine x sine x. And then say, oh, sine x over cos x is tan x. And I also have another sine x. So this part here is the tan x, and then you have the sine x. So what goes wrong sometimes is people do this. Can I erase this? You got it now, okay. So they will look at this and they will do the following, because sometimes you're allowed to do it, but you're not allowed to do it here. They'll say, I want to get rid of the denominators. I'm going to multiply both of them by the denominator. I'm just going to multiply this by cos x. I'm going to multiply this by cos x. That will cancel the denominators, and I'm left with this. Now, that's what you had written. I don't know if that was what you thought of doing.
I don't think that's what I started doing. I think I just totally forgot to put the
Okay, so that was my hope, is you just forgot to include the denominator. Why? But I think this is important, because later on we will be allowed to do this. Why are you not allowed to just multiply both terms by cos of x? Or better yet, when would you be allowed to do that? Do you know?
Would you be allowed if it was an equation?
If it was an equation where there was another side that you also multiplied by cos of x. So if this thing in brown was this, and let's be clear, it's not, then you would be allowed to get away with doing that, which is not what you did, but some people still might. Okay? It is an important, so this is all wrong now, but it is an important point that it's easy to get caught up in all of the numerator work that you forget about the denominator. That's good though? Okay. So we'll take a look at number 16 here. And again, you really need to work at this. This is why we have this whole day of doing this. But you also need to learn from what I'm going to show you. So 16 has cotangent of x plus cosecant of x over secant of x plus 1. You're told that secant of x is not allowed to be negative 1, because then you'd have 0 in the denominator. That's not that important. I don't think there's much you can do here useful anyway, other than writing everything in terms of sine of x and cos of x. A cotangent is cosine over sine. Cosecant of a rotation angle or an angle is 1 over sine. Secant is 1 over cosine. So that looks okay. So we've created a complex fraction. See, we're going to keep running into this complex fraction all the time. So you need to know that these things are, they're problematic. They're roadblocks in terms of trying to get to where we want to get to. We have to get rid of those. We have to clear the road first. And I'm going to do that by multiplying the top and the bottom by, I mean, it's the lowest common denominator, but by whatever is necessary to get rid of those denominators. There's a reason why you multiply top and bottom by sine x cos x. And it's not just, well, because that's the lowest common denominator of all those many denominators. It's because it'll do the job. There's this plus sign here, which tells me that I have to distribute this when I multiply it in by multiplying by each of the two terms. The same thing here. There's a plus sign here, so I'm going to have to distribute this. You don't write that. Don't think that you need to write that down to explain to a marker what you're doing. I'm just teaching you what you're doing. So when I multiply that cos x over sine x, and I hope you understand when I point to this, I'm talking about the whole fraction. When I multiply cos x over sine x by sine x cos x, the sine x's cancel and I'm left with cos x times cos x, which is cos squared of x. And then I have sine x cos x times 1 over sine, which leaves me with cos of x. And when I do the same thing to the bottom, the sine x cos x multiplied by 1 over cos will result in the cosine x's canceling, and then leaving me with a sine of x. And then I have sine x cos x. So a question for you. I was going to ask, are you allowed to? But you're not. So I'll just ask, why are we not allowed to do that? This is the fundamental of rational expressions. When can you cancel and when can you not? Why is this mathematical lunacy? Why can't you do that?
Because on the numerator we are adding.
Because you're adding, so it's not that cos x in the denominator is not a factor. By the way, we're adding in the numerator too, so the cos x based on that plus is not a factor. It turns out cos x is a factor of the top because we can factor it out. So yes, the answer to the question is you cannot cancel these two cos x's here and here because you're not canceling a factor. So how do you decide what you can cancel? Factor. I don't know. For those of you that had me for Math 20-1, when I started rational expressions, the whole board was filled with one word, and it said factor. If you go, oh, I don't know what to do, and I say, have you factored? And you go, no. Well, then I'll say, well, you need to factor first. What can I factor out of the top? I can factor out a cosine of x. And I'm left with cosine of x plus 1. This is where many of you will start to see what the answer will be. In the denominator, I can factor out a sine of x as the greatest common factor and be left with 1 plus cosine of x. So going back to our conversation, Armand, that I said, oh, and by the way, cosine of x happens to be a factor of the top. It's not what cancels, though. What cancels are these two factors. You should know a plus b is the same as b plus a. And it's at this point, James, that you're left with cos of x over sine of x, which you should recognize as tan of x. And I think that's where we're going here, right? Is that okay? All right. After factoring that cos x plus, cos x out of the top and the sine x out of the bottom, is these two binomial factors cancel, and you're left with cosine of angle x over sine of angle x, which is tangent of angle x. What's that?
Isn't tangent sine over cosine?
Oh, cotangent. I misspoke. Is there? I hope there's a cotangent there, and I hope the right answer is cotangent. Yeah. Okay. Thank you. It's cotangent. Yeah. And not making excuses, but remember what I've told you guys multiple times. You cannot do math without making mistakes. Look, like you should, by the way, be impressed with the work you're doing. If you look at what you're writing here and the work you're doing today, and if I showed that to you, I went in a time machine and went back 2 weeks and said, this is going to be you, you wouldn't believe it. right? But you're going to occasionally make mistakes, so, yeah.
I don't know how to move forward with this question.
Which one?
18.
18? Okay. So I want to talk about 18 now. What are the non-permissible values of this equation, of x for this equation? So we have cosecant, which is 1 over sine. We have tangent, which is sine of x over cosine of x. And we have equals secant, which is 1 over cosine of x. You get non-permissible values in trigonometry always for the same reason, because you end up dividing by 0. Okay? So this is a fraction. This 1 over sine x is a fraction. And that means that this denominator is never allowed to be 0, because then 1 over sine of x will be undefined. So that's a denominator, and we can write then the conclusion is that this is true. Sine of x is not allowed to be 0. Period. Now, let's move on. We also have a denominator of cos of x. Now, we happen to have a denominator of cos of x here too, but it doesn't matter. We're going to, the old expression, kind of a weird one, kill two birds with one stone here. They're both over cosine of x, so cosine of x is a denominator someplace, and that means that that cosine of x is not allowed to be 0. You cannot divide by 0. So if you're dividing by a is not allowed to be 0. If you're dividing by cos x is not allowed to be 0. Now, the way you answer this is you really think this way. Forget about that statement or that question we're doing right now. If sine of x is not allowed to be 0, let's find out where sine of x is 0. And I'm a unit circle kind of thinker here, and I would encourage you to be so as well, that if you take a look at the locations on the unit circle where sine of a rotation angle is 0, we're looking at a y coordinate. Boy, as a math teacher, I wish somebody would have made a decision 100 years ago to never use x for an angle, because then I wouldn't have to have this conversation every time. The x in sine of x is not a x coordinate on the unit circle. It's a rotation angle. So the y coordinate is equal to 0 at multiples of pi. So those two positions. When I take so what that means is that if pi is a value of x that makes sine 0, x is not allowed to be pi. X is not allowed to be all of these numbers. So those are non-permissible values. Now the same thing goes here with your cosine of the rotation angle equaling 0. On the unit circle, cosine is the x coordinate, and the x coordinate is 0 here and here. So is there a way for us to condense a description of all four of those positions in terms of rotation angles? And the answer is yes. We can say those are all multiples of pi over 2. And that's why the correct answer will be C. Does that help? Yeah? And again, there's something to be learned from every one of these that I go over. And the big thing to be learned here, Brooklyn, is that, I'm going to rewrite this first of all so I can refer to things a little better. I have secant of t multiplied by sine squared of t multiplied by cosecant of t. The important aspect, the most important algebraic aspect of this statement or this expression is the fact that those pieces are being multiplied together. So once we write everything in terms of sine and cosine and clear out the complexity of the fraction, we can just cancel wherever we want because it's a single fraction. It's going to be. So secant is the reciprocal of cosine, am I right? Sine squared is already a sine trig ratio. Remember, we're writing everything in terms of sine ratios and cosine ratios. Cosecant is the reciprocal of sine. It might help now. So there's no complex fraction here, because when you multiply fractions together, you simply multiply across the top and multiply across the bottom. We're just ending up with a single fraction with sine squared of t on the top and cosine of t, sine of t on the bottom. It might help. I know that, well, I'll ask the question, how many of you see that's tangent of t? Okay. It might help for you to rewrite that sine squared, as sine of t, sine of t. And then on the bottom, cos of t, sine of t. You never need those brackets in a situation like this, but I'm pointing out to you that factors are things written in brackets that are multiplied by other things written in brackets. And factors are the only things you were allowed to cancel. So what we're left with is sine of t over cosine of t, which is tangent of t. Is that okay, Brooklyn?